Snowflake stores the data in Amazon S3 bucket. When you load data into Snowflake, Snowflake splits the files into micro files, and then it stores those files in the Amazon S3 buckets or Azure Blob Storage. And when you query data or when you load data into Snowflake, it uses virtual warehouses to load or retrieve data from Snowflake. In a traditional data warehouse platform, you have one storage layer and you have the common database appliance that is being shared between the ETL team, the development team, and the reporting teams. But in Snowflake, you can have multiple virtual warehouses, and you have the common data layer which is being shared across all the virtual warehouses. And Snowflake claims that there won't be any downtime between the read and write operations between the virtual warehouses. The Snowflake architecture consists of three layers: the database storage layer, the query processing layer, and the cloud services layer. When you load data into Snowflake, Snowflake converts the data into microfiles, and it stores the files in Amazon S3 buckets. As of today, Snowflake charges $23 per terabyte of storage, which is exactly the same price that AWS charges. Next is the query processing layer. It uses Amazon EC2 instances behind the scenes. So you can have a separate virtual warehouse for loading data into Snowflake, as well as you can have a separate virtual warehouse for reading data from Snowflake. Each virtual warehouse is independent, isolated, and it could scale up or down based on the demand. The cloud services layer is the brain of Snowflake. When a user fires a query, it spins up the virtual warehouses automatically, and it copies the data from Amazon S3 buckets to the virtual warehouses, and it does all the work, and it returns the results to the end user. The cloud services layer also maintains the metadata of all the tables and all the columns. It is also responsible for handling the transactions, security, and the infrastructure and access control. So if you sign up for Snowflake, your bill will contain two sections. You will be billed for the storage used in terabyte, and you will also be billed based on the compute credits used by your virtual warehouses. Snowflake uses virtual warehouses to execute your queries or to load data into Snowflake. The virtual warehouse is a fancy term for on-demand computing. For simplicity's sake, Snowflake offers warehouses in t-shirt sizes. We have warehouse sizes from extra small to 4x large. An extra small warehouse has one server, and it will exhaust one compute credit per hour, whereas a 4x large warehouse has 128 servers in this cluster, and it will exhaust 128 credits per hour. You can choose the warehouse size based on your needs. If you're not sure about your warehouse size, you can always start small and then you keep increasing based on your requirements. And you can always auto scale up or down based on the load. Snowflake's unique architecture also brings in exciting new features like time travel, zero copy cloning, and data sharing. We are going to go through all these topics in detail later, but here's a high-level overview. If you have a table with a lot of updates happening, you could use time travel to look at the table. You could see how the table looked like a day back, 2 days back, or even a minute back. Whereas you could use zero copy cloning to clone your production database for your testing needs without having to actually copy the data. Data sharing is another feature of Snowflake, where you can get data from your provider without having to load data into Snowflake, or you can share data with another organization who's with Snowflake. Every company needs a data warehouse, so investing your time in learning the technology is well worth it. Data warehouse is